so let's look at this problem. So this problem says estimate the mass in grams of CO2 produced in 2004 by the combustion of 3.4 times 10 to the 15 grams of gasoline. And the gasoline is octane. All right, so what's happening? So first, let's see, what am I looking for? So let's ask that question. What am I looking for? So I'm looking for the mass of CO2. I want the mass of CO2 in what units? In grams. That's what I'm looking for. All right, what did they give me? They said it was combustion. That might be helpful. And they gave me the mass of gasoline, which they said was octane. So they gave me the mass of a different compound. So that's all they gave me. They gave me the mass of this guy, and they want me to find the mass of that guy. So let's think. I have the mass of one thing. I have the mass of my octane, but I need the mass of my CO2. So I'm trying to go from the mass of one to the other. So there's only one way that I can go from one thing to something completely different. That's why it's important to write these formulas with what I was given. So I have octane, and I'm trying to get to CO2. There's only one way I could go from one to the other. That is stoichiometry. Well, how do I do stoichiometry? I have to have a balanced chemical equation to be able to get the coefficients. So this is where you'd have to write a balanced equation. So that's why it's important to know what's happening. So what's happening? They said that CO2 is produced by combustion. So do we know what combustion is? Yes. So we already talked about combustion a little bit. Combustion is a reaction where I take whatever is being combusted and I add oxygen and I get CO2 and water. Now, I kind of set you up on this one. I already gave you the balanced equation for combustion. So I'm kind of saving us a little bit of time in the previous problem, okay? So what you would have had to do is know that it's octane plus O2 goes CO2 and water and then balance it out. But for us, you could just copy that over. So if you didn't already have this, you would have to figure it out. You would have to write the formulas and do all the steps to balance the equation. All right, so what it says is I'm looking for this guy in grams, and they gave me this guy. So how can I go from here to here? I can only go from one to the other in moles, okay? So what did they give me? They gave me this number in grams. So can I go straight from here to here? No, because he's in grams. So what do I need to do first? I need to put him in moles. So I have 3.4 times 10 to the 15 grams of my octane. To get to CO2, he needs to be in moles. So I need to go from grams of him to moles of him, sorry. How do I go from grams to moles of a compound? The periodic table, the molecular weight, okay? This is old stuff. Grams to moles, the weight on the periodic table. So C8H18. Carbon is 12, so 12 times 8, okay? And then plus my hydrogen, so that's close to 18. So I need to add this up. So when I add it up, I get 114. So if I add this up and I get 114, where does that go? Does it go on top or bottom? It's 114 grams per mole. So that number always goes with the grams. And moles goes on top. One on top. So now I've gone from grams of my octane to moles. So now that I'm in moles, now that I have the correct unit, now I can switch him. So I had to switch the unit before I could switch the guy. So now the unit's correct. So now I can go from moles of C8H18 to moles of my CO2. I could go from one to the other. Because I'm in the right units, I can switch the guy. What numbers do I put here? These are my coefficients from my balanced equation. On top is CO2, so if I find CO2, that coefficient goes in the first blank. Find octane, that coefficient goes in the bottom. So now I go from moles of my octane to now I'm at moles of my CO2. Am I done? What did I want? I wanted CO2, but I wanted it in grams. So now I have one extra step. I have moles of my CO2. I want to go to grams of my CO2. How do you go from moles to grams? Molecular weight, same like here. So to go from moles to grams, I need the molecular weight of CO2. Carbon is 12.01, oxygen is 16. So then I add that up and I get 44. So does the 44 go on top or bottom? It always goes with the gram. So if the gram's on top, the number is going to go on top. And a 1 goes on the other side. So now I went grams to moles. Then I went from moles of one thing to moles of the other, and then I put it in grams. So to do the math, it's this times 1 times 16 times 44, get that answer. 114 times 2, get that answer, and then divide top by bottom. And your number comes out to be 1.0 times 10 to the 16 grams of CO2. Now you might be asking yourself, okay, is that a lot? Well, let's think about what it's saying. It's saying that I have some gasoline, a good bit of gasoline, and this is how much CO2 was produced in 2004. So this is how much gasoline was used up in 2004 and how much CO2. So it should be a lot of CO2, because remember that's the whole issue with cars, is we release too much CO2 in the environment. All right? So it's important to know what is the unit and what it is for. And this is a very common problem, so you need to make sure you can be able to do this. You need to be able to go to grams of one thing to grams of something completely different using stoichiometry. This is the new part, going from one thing to another in moles from my coefficients, my balanced equation. All right, so we're going to do another practice so you can really practice the stoichiometry. So that's what we'll do on the next lecture.